Hello, welcome back. I'm very happy to see you again here at the Jörn YouTube channel. Today I want to talk about the dual bushes, the bush halves and the coil bushes and explain what they are for and what they are used for. Enjoy! Yeah, well, as I've said, today's topic is bush halves, dual bushes, and some special variations of these, special variants of these parts. But before I want to start, I want to talk a little bit about where we are today. Today we're in the testing room where our testing machines are situated, which we are using to measure the most important characteristic of our parts, which is the stiffness of the part. So you see here a podest which is movable, and you can see here a force measurement unit, and you see here some devices where we apply our parts to, and we move this table up and down and push the part against this stamp here, and by measuring the force and the displacement we get the stiffness. However, it's not just that simple. It's not just put the parts there and measure. That's a little bit more tricky, and some experience is required, as well as very well determined boundary conditions. Of course, one thing is what needs to be tracked is the ambient temperature. When the temperature would be very much different, you would end up with different results. Another very important topic is the velocity of the movement of that table. It's about very few minutes, very few millimeters per minute. Sorry. That's also very important. Next thing is, if we would measure the movement of the table and the force and take that for the evaluation, it would be misleading, because the stiffness of some of our parts is in the same area where the stiffness of these test machine is. So, but what we then would measure is the total stiffness, machine plus part. But if that's in the same area, we would measure wrong values. So we have to measure the displacement of the part directly. That's very important, but that's it for the test machine. We have two of these machines here. One is this one, and we have right over there another one. And it's very frequently used for our parts. However, today we want to talk about bush halves and dual bushes. What is a bush half? Bush half is a bush cut into two halves. That's why it's called bush halves. It's consisting of an outer metal layer here. It's a normal steel, and we have another steel layer here on the inner side. Between that two layers we have the rubber, and in most of the parts we have a very thin rubber layer on the inner side. It's to reduce the friction by twisting. That's in some cases required, not for normal purpose, but for some special high twisting events. That's a bush half. This looks very similar to that. You can call that two bush halves, but we call it dual bush because it's a little bit different to the part before. Two halves are connected with a very thin rubber skin, rubber sheet. That's helpful in order to improve the assembly. Later on I will explain you a little bit more. What are these parts used for? What's the purpose? I mean, last time we had the video about the slit bushes, and when do we use a slit bush? When do we use a bush like that? Well, not all environments are like allowing to assemble the parts in by pushing it in the actual direction, because there might be the inner pin is somehow bended, so you can't push it over the radius. Sometimes you have very large parts which are just too big and the push-in forces would be too high. So for these applications you also can use bushes like that. Then you have parts applications, for example in wind turbines, where you want to replace or exchange some parts with a crane which is inside of the wind turbine. You want to just lift the generator with the gearbox, lift it up with a crane, and you don't have a press available there. So you just want to put then the spare part into the housing, put cover, close it, screw it, that's it. That's what you want to do. And for these applications you want to have bushes like this. I just mentioned stabilizer bars. What is a stabilizer bar? There are many different names for the same thing. Some people call it stabilizer bars, other people call it anti-roll bar. What is it doing? And it's like a U-shaped, very flexible steel part. It's round. For a boogie of a train, for example, it's like that diameter. You also find these parts in a truck, a little bit smaller depending on the size of the truck, of course, and passenger car much smaller. But the basic function is the same. It's like U-shaped, and it's very, very stiff, torsionally stiff in that direction, but it could be bended, and it will bend during the application, and it helps to reduce the rolling vibration mode. So what I'm doing here, you don't want to have that. Yeah? And we, as a rubber by metal making company, we love those stabilizer bars because you need 4 rubber metal parts to fix them to the car or to the vehicle. You have 2 in the stabilizer eyes, and you have another 2 on the back of the stabilizer bar to connect the stabilizer with the chassis or with the suspension, depending on which direction you apply those parts. Yeah, as I've mentioned, you find those stabilizer in passenger car, trucks, and boogies of a train. Good. By the way, I have to mention that these dual bushes and the bush halves as well are inventions made by Jörn. So that's important to know, so we are the originator of those kind of applications. Okay, I have prepared in the meantime a fitting room which is normally used to measure the stiffness of the parts at that machine, but it's a good way to explain you how the parts are assembled in reality. Well, let's start with the bush halves. Well, let's take this pin as a simulated stabilizer bar. You can easily mount the upper part, no problem, but the lower part, very difficult. So if that would be a real stabilizer bar, I mean, you can't handle it as one person. However, in that case I can do, but I mean, I'm sure you can imagine what I mean. So this is then just put into the lower part of the housing, then the stabilizer comes, upper part, the cover. In reality, it's not that massive. It's just that massive because it's made for a testing machine, you know. Just understand. So that's very easy. Oh, this part is a little bit more difficult. So that's the bush halves. Okay. Dual bushes, different. When you can see, it's the 2 halves are together even if you just handle it like this, and it's open at that point, you see. It's very easy to move the dual bushes into the fitting room with just that movement, and it's not getting lost. So you have more flexibility for the assembly in the assembly shop. But the basic principle of mounting it is of course the same. You take the bush, the dual bush, around the stabilizer bar, put it into the housing, the fitting room, and close it. And of course then you have to tighten the screws. By tightening the screws, you apply the pretension. The pretension for that principle is the same as it is for slit bushes. This radial pretension gives the durability. I've talked about that last time in the slit bush video, very detailed. Please, if you want to know more about that, please go back and view that video again. As I've mentioned before, these dual bush as well as the bush halves are inventions and of course patented by Jörn. So the competition can't produce like this, couldn't produce like this. However, this part is a pretty much great success for the Jörn company, and competition wanted to have something similar. So what did they do? They moved what our idea was, the connecting rubber layer between the two halves from the inner metal sheet to the outer metal sheet. Sounds as if it had not a big impact, but however in reality it really has. I mean, of course that's a legal design. Well, let's have a look to the two designs. And the main difference is very visible, and of course I don't have to say many words about that. Our concept is very good and very easy for assembly. This one is a little bit better than two bush halves, but not as good to handle as this one. Very clear. Okay. I want to talk about some other variants of these products. First, we have this kind of bush. We call it coil bush. It's basically similar to the dual bush. It has two halves connected with, in that case, a thick rubber layer. But inside the metal sheets here are two metal sheets as well, same as in a dual bush. And you can open that bush, move it, and close it when it's fitted at the stabilizer bar. That's possible. Why this design? Well, this is just cheaper. It has just one metal layer, less rubber, so it's easier to handle. And why not always this one if it's cheaper? Well, it's very simple. It's not as robust. It can't bear as high loads as the dual bush can. So for lower requirements in terms of load, you can use this coil bush. For higher requirements, you have to better go to dual bush. So this is a very standard design here in that what you see here. That has one metal layer, two rubber layers. We have very few applications where we have two metal layers, but a coil bush with two metal layers is very close to the costs and so on of a dual bush, and then it's better to move to the dual bush because it's more robust. But for low-loaded applications, no problem to use that. We have a dual bush like this with a conical inner shape. This has a plastic inner layer, and the cone is built by rubber. It's because of the specific shape of that anti-roll bar in that case. But beside that, it's a normal dual bush connected with a thin rubber layer, and you can open it as all other dual bushes as well. It's a double layer dual bush with two rubber layers and two further metal sheets, so it's the same concept as it is for the slit bush, with a multi-layer slit bush, as I've explained in the slit bush movie last time. Another specialty of this bush are the bumps here. They have counterparts in the housing, and that increases the actual push-out force significantly, and that's designed for applications with very high actual loads. One, especially here. Then we have another special part. Is this one? This is a bush half, and that's one of the cases where the push-in forces of a normal slit bush would have been much too high for designing a slit bush. That's why we designed a bush half in that case. It's a bush half and not a dual bush, because it gives us advantages in terms of positioning the part on the tool, on the injection tool for the rubber. It has 4 rubber layers and different metal layers as well. This is standard steel. Well, that's it for the bush halves, for the dual bushes, for the coil bushes, for all the other applications. If are some questions remaining, I would be very happy if you contact me. You can contact me via writing a comment here at YouTube. You can contact me by email. You find all the contact data, all the contact options down in the info box of our YouTube channel. I would be happy if you like that video. I would be very happy if you would come back and if you follow us here at YouTube. At the end, I want to say thank you very much again to my team helping me to do this movie. First, it's Michael Schliebel, the man behind the camera and who's doing the cut. And maybe I can ask him sooner or later to show up in front of the camera, rather that you can see at least his face one time. Another person I want to say thank you is Miriam Großmann. Ms. Großmann is responsible for all the improvements of our videos we do, and we did it last time. She's our advisor for the social media marketing, and she gives us very, very helpful tips and advices how to make a movie like this better, more convenient and more entertaining, of course. Thank you very much. See you again soon. Bye bye.